together. Okay, so that's how we determine the molecular mass or molecular weight of one molecule. Okay, a simple calculation, multiplication of the number of atoms by its atomic mass, and then you add everything together. Okay, now when we try to figure out the quantities of the chemicals there, and molecules and atoms are so small, we can't really count a particular molecule out. So we have to have a counting unit to determine the quantity of the molecules that we have there. Because what matters here is that in a chemical reaction, how many particles of each molecule or atom you have will determine how much product you're going to end up with. So chemistry is a quantitative science, so we need a counting unit. A counting unit in this case, in chemistry, is what we call a mole. 1 mole is the amount of substance that contains as many particles as there are in 12 grams, exactly 12 grams of carbon-12. Okay, so what we're trying to do here is that we're trying to relate the number of particles to a mass. So we're talking about 1 mole is the amount of substance that contains the same number of particles as there are in 12 grams of carbon. Now, how many particles are there in 12 grams of carbon? And the concept of mole is defined so that we can actually equate the amount of matter, mass, gram, to the number of particles there. Now, the standard mass, and the standard is based on carbon-12 isotope there. Okay, and we know that each carbon atom, carbon-12 has exactly 12 units in there. And then based on the relationship there, and 1 mole of carbon-12 equals to 12 grams there. So we can come up with this conversion there between 1 atomic mass unit to the mass in grams there. Okay, now 1 mole represents 6.0221415 times 10 to the 23rd. That many number of particles. And this is the number that we call Avogadro's number. Okay. Now, Amedeo Avogadro, an Italian scientist, came up with this idea. Now, when he was studying chemical reactions between gases there, he found out that gas molecules always react with one another in whole number ratios. So he proposed there has to be a relationship between the number of particles, number of atoms, or molecules, and the mass of the quantity. Because when you measure the mass of a gas there, you're measuring them in grams. But the chemical reaction always happens in whole number ratio. So there has to be a relationship between the number of particles and the grams of the gases there. And then after a fairly complex calculation, we determined the number is 6.022 times 10 to the 23. This is the number. This is what we call the Avogadro's number. This number is something that we need you to memorize. A matter of fact, well, when you're taking this as exam, Avogadro's number is an information given to you, so you probably don't have to memorize it. But when you take chemistry classes, there's something that you have to memorize. So you better remember this number, 6.022. You don't have to go to that 1415 then. 6.022 times 10 to the 23. Now, what does this number mean? It means for 1 mole of any substance, you have this many particles of that substance. If you have 1 mole of oxygen atom, you have 6.02 times 10 to the 23, that many number of atoms. If you have 1 mole of oxygen molecule, well, oxygen atom, oxygen molecule are different. Oxygen molecule is a diatomic molecule, O2. So the number of oxygen molecule, if you have 1 mole of oxygen molecule, you would have 6.02 times 10 to the 23, that many number of molecules, O2, as a unit there. But the number of atoms there is 2 times that number. Okay, so that's what the Avogadro's number is all about. And Avogadro's number is 6.02 times 10 to the 23. And the basic idea is that 1 mole of anything, 1 mole of anything contains this many number of units for that particular substance. Okay, so it could be atoms, it could be molecules, it could be ions. So when you say 1 mole of anything, and the number, this is the constant, 6.022 times 10 to the 23, or it could be dollars, and that's a lot of dollars. 6.02 times 10 to the 23, that's a humongous number. And it's a very large number representing something that's not determined by counting. It's actually something that's determined by calculation. Okay, we'll give you some examples that are trying to help you to understand the mole concept. And chemists are just like cooks, and when you're doing cooking there, you have to have a counting unit for materials that you're using there. So if I send you to a bakery and I ask you to buy a dozen of chocolate chip cookie, which is one of my favorite, you get me how many? Well, a score. 407 years ago. You still remember that Gettysburg speech, right? By Abraham Lincoln. 407 years ago. That's 87 years ago. A score would be 20. 144. How about a mole then? 6.02 times 10 to the 3. Don't get that much chocolate chip cookie. You can't assume it. And that's a huge number there. How big is it? If you have an atom the size of a ping pong ball and you chain them together, one next to another, 1 mole of ping pong ball would actually spread over the surface of this planet and make a layer 20 miles thick. That's how big the number is. So if I ask you to count out a mole of hydrogen atom, and you have a computer that can count 10 million atoms per second, it would take about 1 billion years to count out 1 atom. So it's physically impossible to count the number of particles out in this kind of quantity there. Okay. Now, how do we determine, if I ask you to give me a mole of hydrogen atom or iron atom there, how do you count them out? Well, you don't. You weigh them out. Now we have a relationship. Given the periodic table, each mole of any substance will have this many particles. Each particle represents, we have atomic mass for each of the particles there. So the number listed in the periodic table also represents a mass of that particular type of atom in grams for each mole of those particles. Okay? So if I ask you to give me a mole of hydrogen atom, you don't go and count out 6.02 times 10 to the 23, that many number of hydrogen atom. Rather, you measure 1.0079 gram of hydrogen atom, if you can do that. Here's 1 mole. Don't ask me to count it. I won't have the time to actually count the numbers out. And well, if you measure out that many grams, that means you have 1 mole. 1 mole is 6.02 times 10 to the 23. So the important thing here is that mole allows us to count atoms and molecules by weighing them. We can simply measure them out. Given the periodic table, we would know 1 mole of any atom, how many grams of, for each mole of atom there, how many grams they weigh. Okay? So we would actually, using the concept of mole, we can actually measure out mass instead of counting. And this is another example, and as you can see throughout the course there, when we are doing examples there, the analogy that I'm using is always more than often it's related to food. Well, okay. So when you go in grocery store, when you buy shrimp there, and you see 26 to 30 shrimp per pound, that means when you count 26 to 30 shrimps out, that's the size of the shrimp there.